Hi everyone, welcome back to Java 1 for All. And in this video, we are going to finally start something very interesting and probably something that you will be using every day from now on. That's object orientation. So let's understand a little bit of what we have been doing so far. Basically, everything that we did so far is just like an introduction. It's kind of a programming logic for you to get started with Java. Nothing really special. Everything that you see here we have in every language out there, and now we are going to do something that's very specific to Java. There are some languages that they are also object oriented, for example C# or Python or JavaScript, but this is the Java way of doing object orientation. And to understand a little bit of object orientation, there are several concepts that we'll have to go through, and the first one is understanding what is classes. So before we move on, let's first restructure a little bit our project here. We have here Java 1 for All .introduction, and now what we are going to do is create a new package. Just right click, new, and then package. And let's first create a new package called Java Core. And now dot, and this is very ugly, and never do that anywhere else. Because yeah, it will look really bad. But first type in big A. Why? Because now we are going to keep an order. We are going to have so many packages that I would like you to later on understand the structure and the timeline of everything that you were doing throughout probably several months. So A, introduction, classes. So you should never do something like this, please, never. And now that we have here, actually I did in the wrong place, just shift F6 and just remove introduction. It's not part of introduction, and I click on refactor. So this is how you should see your structure. Now that we have the package, let's understand what we have so far. Basically, we have been working with primitive types. So for example, we can have here the age, 21, and we do have a variable that's a primitive type, that's int age, integer age. So the thing is, primitive types are basically what they say, primitive, just have like some bits inside the space in memory and nothing else. And if we have something different, for example, we could have character sex. So for example, not sex, gender. So we have character gender, and this could be like male or female. And then we could also have not primitive type, but we could also have something like string name, and here we could have Luffy. And this one we can add the single quotes to represent that this is a character. Okay, so what's the problem here? The problem here is that they are like in their own kind of world. We don't have anything relating them together. So I don't know if this 21 is like age, Luffy's age, or if this M it's related to the age 21. So there is nothing that says that they are together. So this is where the object orientation will come into play. Basically, when we talk about object orientation, the first idea was try to map the real world, what we have on our daily lives, to something that the computer can understand. And the first concept was kind of creating classes, creating objects. And this could be an object. So instead of having the space in memory with them separately and kind of having to figure out how to put them together, why not have everything inside one big space in memory? So what happens if we do something like this? Let's say that we do have something like this. And if we set back, boom, we do have now, and I don't know why it's weird. Let me get this one. There you go. So now we have one space in memory, and inside this space in memory, we do have everything together. So they have their own spaces inside this space, but let's not get that technical. And this is what we call an object. And you can see that object, we have attributes inside, and each one of these attributes, they have their own values, but they are all tied together in one space in memory. So how do we create objects? Well, we kind of have a blueprint, because object is always a result of something, and this something is class. So for example, what can you think that could have age, gender, and name? Well, several things. For example, could be employee, could be person, could be student, could be professor. So there are several ways to represent this. And this is where it comes into play, the mapping reality to virtual world. Basically, we have to decide what this will be representing. And we can say here, for the sake of simplicity, that this is a student. So I'm saying that this is a class student, and the student here, it's giving birth to this object. So how would that look like into when we talk about coding? So first we have to define the blueprint. That's the class for creating objects. Let's do that here. We do have a couple of things that we have to take into consideration. First is that we are not going to have public static void main in all classes anymore. And why is that? Because this is only when you want to execute. But in this case, if we go back, our student, well, we don't need to execute the student, we need to create a new object. So basically, it's just a blueprint that will generate new students. So we are going to separate here into two other packages. First one, and we are going to call this under this introduction classes, we are going to call it domain. So usually the package domain or model are the classes that usually represents whatever we have in the real world. It's kind of the business core. So if we had a big database, students or professor or classes or seminars, things that would be stored in the database usually goes into domain package. So domain model, there are several different names that you can use. And I will create here a class, and I will call this class, guess what? Student. And right now, I'm not going to create a public static void main anymore. I'm going to just create the attributes. So basically, an object will have attributes and also behavior. So the characteristics of that object will be the attributes, and what that object can do will be the behavior, and we are going to later on learn about methods. So we are going to focus right now on only the characteristics, the attributes. And I'm saying here that we have three: name, gender, and age. So okay, so we have now three attributes. And I said to you, these three attributes, they are representing these class characteristics. For example, these are the students' characteristics. So we have to map whatever is in the real world to what's relevant for our system. In this case, for example, hair color, something that, well, a student will have, but in this case is not important for our system. So this is what is important. And the public is something that we are going to learn later on, is access modifier. So don't mind it right now. Just create the attributes like we have here now. And then I will create a new package, and I will delete domain because I want a sub package of introduction classes. I will delete domain and then a introduction classes dot test. And here now you can see that we have two packages, and now we are going to follow from now on this pattern. The test will be the classes, the package test will have the classes that we have the public static void main. So we have student, right click, Java class, student test. Let's add 0, 1 because I'm not sure yet if we're going to have 1 or 2. So we have student and we have student test. Test, we'll need public static void main, because if I go back here and if I press Ctrl Shift F10 and I try to execute, nothing's happening. But if I click here, this class is going to be executed, so you will see something going on. But it's not this class, it's the class that's written right here in this drop down. Okay, so now we have to create a variable. We have to create that object. And how do we do that? Basically, we have two parts: the reference to that object and the object itself. So the reference is student, and when I press enter, you can see that we do have a new line right here, import. So this import, it's basically telling Java that we do have a class inside this package, and this class is called student. If I remove, you will see this error saying, hey, I don't know what is this symbol. What do you mean by student? That's why we have the import right here. Another option is, let's say you don't want to import. You have to write exactly the whole thing. You have to tell where the class is, including the package. So this also works. But well, can you imagine if you had like 10 variables here, how ugly this would look like? That's why we have import. So basically it's just a shortcut for that whole thing, the whole line that you saw here. So first we have to create a reference variable, student. And now that we have the reference variable, we need an object. Right now, if I just create this variable and I try to print this, for example, student, you will see that, oops, this is a local variable. So this means that it should be initialized. Since this is an object, we can initialize with null. All objects will be initialized with null. And this doesn't look pretty. We need to give this reference variable an object. And you know how to create objects because you saw that with arrays. New, and then the type student. Be careful to not type student test1, otherwise you have an error. So what I'm saying here, and remember carefully about these words, I have a reference variable and its type is student, and I also have an object of the same type, student. So basically a student's reference variable is having a reference to a student object. Why is this so important? Because later on we will see that we can have a different variable reference here pointing to a different object. So what we have here is this. I will copy exactly this line so you understand what I'm doing. So basically this is what's happening here. You have a reference variable, and this reference variable is having a reference to a whole object. William, how do you do that? If I just execute this program now, you will see like kind of where this object is. Memory, well, not exactly the memory location, but yeah, this is representing an object. Now I want to access these spaces. I would like to, I don't have anything, and I know that I can access the space memory through my reference variable. So basically, think as a reference variable as like a remote control. Imagine that you have a TV and you have a remote control in your hand. That remote control that you have in your hand, if you press like the power button, who is going to execute the action? Is the TV. So in this case, this is the remote control, this is the TV. So if you have YouTube and you click on YouTube on your remote control, who is going to execute the YouTube? The object. So basically, this is the same principle. We have student, and we would like to access the space memory, the action of the age. Basically, we have to call student dot, and we have these options right here. So for example, age. So I'm telling now that through this reference variable, I'm going to access this tiny space inside this object, and I'm assigning a value to this variable that's 21. And I will do the same, Control D, Control D. The same with name. This one is Luffy. And here, gender is male. Even if I execute now, you will see the same results because, well, I need to print whatever is inside, not the reference. So when I print that way, this is what I'm having. So basically, this is this. So this big line is this reference right here. But I need to access these tiny spaces. I did that to assign values. Now I want to print. So basically, I will do the same. Student.age, student.name, student.gender. And if I print now, Ctrl Shift F10, I get the results. So basically, this is what class and objects they are. Class is kind of a blueprint that will generate or can have like multiple different objects, and each one of them is going to be different. It can be the same, I mean, in terms of you have the same data inside, but yeah, the objects, they will never have the same space in memory. They will always be in different spaces. But let's not get that complicated. I think it's enough information for one video. Let's continue in the next one talking about classes, because I would like to go into more details and I would like you to get a really good understanding, because this is the basis for everything from now on. So I hope you enjoyed. See you in the next video. Bye.